Hello everyone, just getting ready to start streaming here. I'm not really sure what we're going to do because it's been a while since I've made any videos. It's been busy with holidays. There was Thanksgiving, it was Friendsgiving, and then there was like a several Advent of Code stuff that I was doing, so that was just taking a lot of time. But I want to get back to our regular videos, which is like we're doing some Haskell, we're doing some Atari assembly programming. We're also doing some COBOL for fun. Nix, Rust. Wow, that's a lot of stuff. So I figure we should go back and look at what's actually like what we were doing before. All right. Sorry. Just trying to understand what I'm looking at. I still don't understand YouTube and Twitch stream very well. All right. Let's see. So, what do we want to work on today? I think I'm kind of leaning towards Nix because I'm starting to forget what we're doing on Nix. So, let's take a quick look at that. What were we doing with Nix? Okay, here's my browser. We're going through the tutorials, and we've already learned the language basics, so we know how to program in Nix, that's for sure. I've been writing Nix code for Advent of Code, so that's, that we've covered. We've done packaging existing software. I have like a Nix cheat sheet too. Where creating a package, I think that was this packaging existing software stuff. Let's try to just take a quick look to remind ourselves how this works. So we have a default.nix. I guess this is our, we're calling call package here. And I remember that basically call package knows how to pass parameters that it needs into the this other program like Hello Nix. And so here in Hello Nix, it needs standard environment and fetch zip, and call package knows how to pull that out of packages. So it kind of just like fills in the parameters. I guess that's pretty neat. And then I guess this is our main like make derivation is basically building. So here we're giving the package name, the version number, and how we get it. And that'll use the basic like GNU configure and compile toolchain to do it. And all you need to run is nix build -a hello for it to work. So maybe we should just review that real quick because I haven't done that in so long. And we'll call this like package nix. I think I have my, I have my editor and everything ready. So let's just try to set this up real quick and make sure we still know how to do everything. I like to type things in because that lets us it gives us another way of remembering how things work. So here we go. We have Nix packages. And I think we can just do like Nix packages here, can't we? I think that's up here somewhere. Fetch tarball. Or you can do with import Nix packages. Packages. equals import. I wanted to do this because I didn't want to type in a whole long name, you know, Nix packages. I didn't want to type this whole like fetch tarball thing. Where were we? We were down here. Right, so when you fetch the tarball, this is actually going to download it and put it into your Nix store. And then Nix packages refers to that file path location. But then import actually will read the Nix packages Nix file and evaluate it as a Nix program. So that's why they have two separate things. We're just doing it in one thing here because we can just import Nix packages. The difference is that when we do this, we're not specifying a specific version. So it's kind of like less good. But for development purposes, we can just do it this way. Config is an empty attribute set and overlays is an empty list. I got screwed here once because I forgot that overlays was a list and not a set, and it caused like complicated problems. And now we can just give it the list of packages that we want to actually build. We're going to build the hello packages, call package. And what does call package take? Just the, I forgot, the path name and parameters to pass it, which is an empty attribute set. All right, so that is our default. And now we have to make a new file for hello Nix. Right? And it takes in standard environment, and it also needs to be able to call fetch zip, which is part of Nix packages. So this is a function. This is how Nix makes functions. This is one parameter, which happens to be an attribute set. And these are names within the attribute set, standard environment and fetch package. And then we have colon afterwards, which means here's the function body. So now we do standard environment dot make derivation. And in this is a function that takes in an attribute set. So we're passing in an attribute set again. And the attributes that it needs are the p name, the version, and where to get the source from, I guess. Fetch zip. So this fetch zip here is the same fetch zip that we have here. It's a function. Fetch zip, and fetch zip is a function that takes in an attribute set. That is some URL. And it needs a SHA-256 because we can't trust what we get. We're going to fill that in a second. So let's get this URL from here. And we'll put it in our URL. And now I think we can run this. Let's split our screen a little bit and go into projects. What was it called? Package Nix. And in here, I think it's like Nix build -a, and then the name of the package that is in here that we want to build. All right, it didn't like hello Nix line 14 because I didn't have a semicolon here. This is an assignment. Function, attribute is equal to this thing, and so it needs to have a semicolon at the end. I always forget that. There we go. Okay, so it said that it's not happy with the SHA, So I think we just grab this part here and we put it in here. There we go. So it told us there was an output. This is the output where the hello program should exist now, which is symlinked by result. So result is pointing to the same thing here. And result should have something called bin hello. And it says hello world. Okay, so we've built something. And then there was another part in here. Too bad I didn't document it. I guess we should go back. Where we needed to do overrides. Hello everyone, if there's someone here. It says there's someone here, so hello. Where are we now? So this is a more complicated build setup where I think we're going to be missing something. Let me just take a quick look at this. We've done this before. We've done this. We've done that. Right. And now here, we wanted to change a parameter that it's taking in hello Nix. So these are parameterized builds. Maybe we didn't do this yet. I think we did, but I don't remember it that well. So let's review it. Let's review it again. So in here, this is the same default.nix, and notice they went the lazy way also because they just did import packages here instead of like giving it the whole thing. And this looks the same here. Hello Nix is the same stuff in here, so that's fine. And now hello Nix changes a little bit. We're going to pass in a parameter called audience into hello Nix. So, but why is write shell script bin? Oh, because they changed how this works. Let's go ahead and do that. Here we have to change this. This takes in write shell script bin, which is apparently a name within Nix packages, and it's probably a function which knows how to write a shell script. And then in here, we're not going to do a standard derivation. Instead, we're going to use the function write shell script, which takes in some parameters. Looks like, I see. So these double quotes here, this is a double quote, and these are two single quotes. The two single quotes means that it's a multi-line string. So this whole thing is one string to it. Hello world. Okay. So this is a single parameter here that has this string inside of it. And it could have multiple strings. I think that'll work too. And yeah, write shell script is a function that happens to exist in Nix packages that returns a derivation. It puts a derivation, I think, is anything that outputs like something that you can use for your config or for your build. So this should work, right? Yeah, so now we do, let's remove result just so that we know it's not there anymore. And we'll run nix build -a hello. And it built something here, which should be symlinked by this result. All right, so let's see what's in there. It's a script probably that has what we added in here, right? So it worked, and now I think I should be able to run that. So there we go. Hello world, okay. All right, what we're doing is we're just reviewing what we've done in the past, just so that I can catch up. It's been a while since I made a video on Nix, and I've forgotten some stuff. I should probably update the Nix cheat sheet to have whatever's in here. All right, so now we're going to pass in an extra parameter called audience. All right, so what's going on here? It's expecting a parameter called audience, and the question mark means it's a default. If a parameter with audience isn't passed in, it's going to be world, which means if I run this now, it should still work. We have to use audience somewhere, so we're going to put it in here. This is a string interpolation, $, and these squiggly braces means that it's going to be interpolated into the string, so it's going to add that in. Let's change this to something a little more obvious, like hello world. And now when we run this, I think it should rebuild. And you can see that it used my default world. That's all weird. Okay, so that I remember now. Pass the parameter audience into the hello Nix. So we're going to look at default where we're calling hello Nix, and it looks like we can just pass in parameters here. Audience equals what do they use? People. There we go. Let's see now. And it says hello people. So we're able to pass extra parameters in through call package. I wonder if I should notate that somewhere. Creating a package. Maybe we will add something called call package. You can pass in an extra you can pass in extra parameters in your default .nix via call package. Example, and then here we will just show this. I think that works. Okay, and then you can use it, and your package will get it as a parameter, like this. Let's see how that looks. Call package, here's our stuff, and here's audience, right. Okay, I think that's helpful for me to remember in the future. Where's our browser? Here we go. Okay. The attribute is passed on to the argument of the function defined in hello Nix. The same syntax can be used to explicitly set automatically discovered arguments such as write shell script bin. Okay. It is widely used in Nix packages. For example, there is often a build go module. It is common to find expressions like call package go program nix, and we pass in a go build go module with this build go 11.6 module as its value to change the default Go compiler versions. I see. All right, so now call packages has some overrides, it looks like. Can be customized after the fact using the derivation's override function. Add a third attribute, hello folks, to default.nix, set it to hello override. All right, let's go back to default. Now we're making a new package called hello folks, and it is hello.override. So I guess this is referring to this hello up here. So since it's referring to another attribute within the same attribute set, we have to make it a recursive attribute set. Sorry, too early. And then audience is equal to folks. So this makes a package, I guess, when we do packages call packages, and then we're overriding some of the parameters. So I think we can do build minus a hello folks, and it'll do this instead. Let's see if that's right. Yeah, the resulting attribute set is now recursive. Otherwise, we wouldn't be able to access hello. It overrides whatever arguments have been passed in the original call package that produced the derivation hello. All the other parameters will remain the same. This is especially useful and can be often found in packages that provide many options to customize a package. So it's like we want everything the same except something. So now we can build it. And now when we run result bin hello, it says hello folks because we've overridden audience from this guy. This guy kind of passed in an audience parameter which overrides the default parameter, which is world, which we see here, right? This is the default here that we hard-coded in. But here it's overriding it. And then we override it again in our hello folks version of it. Okay, we got some NeoVim stuff. That's fine. Interdependent package sets. I vaguely remember this. So we have packages that depend on each other. Let's do that. So here we have packages dot call package. Oh, this isn't actually going to compile because they don't actually give us A, B, C, NIC. So it's not really worth it for me to type. I think they say it here. The following examples do not show the called files as they are not necessary for understanding the principle. So they're not going to show us these called files. So we have A here, and then B is going to inherit from A. So it's going to bring in all the values of A into B. And C is going to bring in B. So there basically is a chain of dependencies here. But D doesn't need anything, and then E needs to bring in C, which is the last in this chain, A, B, C, and D. So that's pretty complicated. Okay. Previously declared derivations are passed as arguments to the other derivations through call package. Yeah, That's this thing here, right? So which means that B will able to access A through A. It's just going to be called A because inherit A is just equal to A equals A. If anyone has any questions, please do ask. All right, in this case, you'll have to remember to manually specify all arguments required by each package in the respective Nix file. Right, so you have to basically type in all these things here. If bnix requires an argument A, but there is no packages A, the function call will produce an error, right? Use lib call package with to create your own call package based on an attribute set. Here we're calling call package is equal to packages lib call package with packages. Oh yeah, here the // operator merges packages into packages. All right. So let's try to understand. It says this requires some explanation. I'm glad I'm reviewing this because this is all like I've forgotten everything in a week. First of all, note that instead of a recursive attribute set, the names we operate on are now assigned in a let binding. Right, all of these are in, this is in a let binding. This is an attribute set, but it's not recursive. Because you don't need to reference call package in here, you don't need a recursive set because let bindings can refer to each other. It's only within the recursive set. Like if B tried to access the variable A, it couldn't in here unless we added the recursive flag. Okay, it has the same property as recursive sets. Names on the left can be used in expressions on the right of the equal sign. This is how we can refer to packages when we merge its contents with pre-existing attribute set. Okay, so refer to packages. I see. So you see like this call here makes a reference to packages, which means that it's going to evaluate this. And in here, it's going to call package for all of these. And whatever it gets back from packages is going to be merged back into packages, which is this top level thing here, right? So in a way, it's putting all your packages into the top name level of packages, which then call package, because that's what it does. It looks inside package and supplies the parameters that a.nix needs or b.nix needs. It's going to pull them out of packages because it's been put in there with this. That's kind of ingenious. Probably that wasn't clear as an explanation. I can try again, but I don't think it'll actually help. But just realize that it's executing this first because it's made a reference here, right? This reference in call package. And here it's going to call package on all of these and then kind of evaluate this, right? But then it takes the packages that we bring in for each one and puts it into packages, which then can be used in the call package function. It's kind of crazy because this call package function is being updated, right? It's basically being changed by call package with, and it's being passed in this updated packages. And I think this is all possible because it's lazy evaluated. So when we get into trying to do call package until we need it, it's still just a function call. Let's see how they explain it. Your custom call packages, which is isn't this the wrong? They wrote this wrong, right? Because it should just be singular. Your custom call packages now makes available all the attributes in packages and packages. Yes, that's this thing here. To the called package function, the same names from the packages taking precedence. Oh, okay. I didn't know it took precedence. So whatever you have in your packages in here is going to take precedence over the default Nix library packages. The last bit may make your head spin. This construction is only possible because the Nix language is lazy evaluated. That is, values are only computed when they are actually needed. This allows passing packages around without having fully defined it. Right, this thing here. We pass this guy around before we actually call all of this. Each package's dependencies are now implicit at this level, and call package resolves them automatically. All right. So really, you don't really need to know too much other than if you're building something, this is a nice way to do it. If you have interdependencies between your packages. This way, by having using call package with, it will always update the call package function to include all the other information from the other packages. So this is a nice thing to add to our cheat sheet. We'll call this like interdependent packages. Use call package with, and that looks like this. Oh, I did that wrong. It's not equals equals, it's like hash hash. All right, so now we have that out of the way. We've done this. What else do we need to do? I thought there was something that I'm missing here where we did something with different phases of compiling. Building with Nix build. Finding the hash, we did all this. Build result. Package with dependencies. We didn't do this. What is this doing? Let's go through this real quick. So this is like sort of a review so far. Hello, how are you doing? Good. On Twitch, Dylan Couture says hello. I'm doing well, thank you. We're like going over Nix right now. And it's going pretty well. I've forgotten so much. I feel kind of bad that I've forgotten so much so quickly. I think you can hear my laundry running. I'm going to close my door. I have a meeting with a venture capital group to their talent acquisition folks to see if there's any consulting I can do for them later today. I hope I don't like get time blindness and miss the meeting. But I need to start like doing some work again because it's been a long time. I haven't like really worked in like over a year, maybe even two, just doing like fun stuff like this. So, but it's time again to make some money. So there's that. I hope the meeting goes well. VCs are fun. They're like they're always so optimistic, you know? They're because they want to believe that they can make the big money. But I figure like a lot of the times VCs like invest money into startups, you know, early funding VCs, and like their startups don't do so well, so they need help. And they need like people who can help their startups. So that's what I am trying to get into. Maybe even like do some workshops for them. I should like talk about Nix once I learn it with them. Um, yeah, there's lots of ideas. All right. Let me go back to where we were. Package with dependencies. Which one is this? We're gonna make one that calls in icat. We don't need this because we don't have a dependency, right? So let's do icat. And then that's going to call in icat.nix. Doesn't need any parameters here. And then we got to make a file called icat. icat.nix. And it needs to take in stuff. It's a function, and then it's going to build. So in icat, looks like it needs standard environment. And it needs fetch zip. That's probably how it's going to get the source code. And then we are going to call make derivation. And we always need pname. So pname is icat package name, right? We give it the version number, which is just some kind of string. And then source. We need to fetch the zip. Now to download the source code, iCat's upstream repository is hosted on GitHub, so you should replace the previous source fetcher. This time you will use fetch from GitHub instead of fetch zip. Alright, so they lied to us. We're not using fetch zip, we're gonna use fetch from GitHub. And all of these must be part of built-ins, right? Like fetch from GitHub. Oh, it's part of packages. There we go. All right, so it's a function inside of packages. That makes sense. So probably we're going to call it here, right? Fetch from GitHub, and it's probably going to take in, I'm just guessing, it's going to take in an attribute set with a lot of parameters. Yeah, just like this. Now we're going to have to pass in stuff to fetch from GitHub. Source URL, which already gives the first two arguments. More are needed from fetch from GitHub. Okay, so we're going to need an owner and a repo. What a cool name, a texter. I think I said that last time I did this. The repo is called icat. Hash must also be supplied. This time, instead of using the empty string and letting Nix build correct an error, you can fetch the correct hash in the first place with Nix prefetch URL command. I see. So I just run this directly. Oh, I need the rev. Where did they get the rev? In this case, the latest release tag is... Oh, you go to the tags page and find a suitable Git revision. So let's do that. Let's go to this here and see if, like, let's say we wanted to build this and we didn't have this. We look at the tags here and we see there's tags and we grab the latest one. And it was called rev, right? Yeah, rev. Git revision. So it can be a hash or a tag. All right, cool. Well, that's useful to know. Set the correct hash. Now run nix build. I wonder, do I have to do it this way, or can we run it the way we used to run it? Let's try running it the other way. So nix build minus a icat. Yeah, so it told us the thing. This seems easier than typing that long, like, SHA prefetch thing. Right? Let's see if this works now. Alright, so I think this is the error that we're supposed to get here. That doesn't look important. Terminated fatal. That sounds bad. Where's the error? No such file or directory imlib2.h. So yeah, that's what we're missing. Right here, right? Nix tried to build what it found, but missing dependencies imlib2. If you search imlib2 on search, you'll find that is already in Nix packages. So let's try that. Where's our search? Okay. imlib2. Yeah, search NixOS org packages is useful. imlib2 is already in our Nix packages. So we have a dependency on this guy. Let's see what we need to do to make it work. If you search imlib2, you'll find imlib2 is already in Nix packages. Add this package to your build environment by adding imlib2 to the arguments of the function in icat.nix. Right, so in here, if I add imlib2, then call packages is going to fill in that dependency, right? It knows how to pull in this from Nix packages. So then add the arguments value, add this package to your build environment by adding it to the function. We did that. Then add the arguments value to the list of build inputs. Aha. So we need a new thing in here called build inputs. And it takes in a list. Makes sense that it's a list. So this is another thing that comes from make derivation. It takes in a name called build inputs. So that's good to know. We should probably add that to our thing here. So we say something about missing dependencies. Pass in through Nix packages if it is there, and call then add to make derivations build inputs. And that looks like this. All right, maybe there's more to it, but I just wanted to write it before I forgot. Then run nix build icat. Uh-oh, now it needs xlib. Now it needs xlib. You can see a few warnings that you should, we need xlib. Finding packages is somewhat involved. Right, there was like a whole number of ways to search for packages, and some of these really sucked. So I remember that I liked just searching inside of Nix the best. And we needed xlib.h, right? Oh, then we're going to just type xlib. And in here we see a whole bunch of Python stuff. That doesn't look right. Maybe we just type x11. And then we see all of these things, but then I see xorg here, which looked good. And then I think I liked this one. Let's see how it says to find it. Yeah, the easiest way. This is the tip. X11 has too many results. That's what we saw, right? X11 gave us a lot of things. Here, just a lot. And so selecting xorg shows something promising. It helps to become familiar with searching the Nix package's source code for keywords. All right, yeah, but we don't need to do that. We can just try x11 from here. So I think that means we have to pass the package in here, which is xorg, right? Because that's the top level under Nix packages. And then I imagine we pass in xorg.libx11 as the build input. Let's try that, see what happens. No rule to make target install. Right, this is a separate problem now. Let's go here. So I think, yeah, what they've done is they've added xorg just like we did, and they added xorg.libx11 here. And yeah, in case it's confusing why they're different, we can't put xorg.libx11 on top here, because call packages is basically going to look for this thing in the Nix packages, and Nix packages is laid out where it's an attribute set with all of these things on the top level. So it only knows how to match like one thing, the top, which is xorg here. And then here we can pass whatever into build input, so we can go xorg.libx11. Once we have the reference to xorg, we can dereference anything under xorg. All right, so now we're failing because, oh, here it says so. Only add the top level xorg rather than the full, as the latter would cause a syntax error. Because Nix is lazily evaluated, using xorg.x11 means that we include the x11 attribute, and the derivation doesn't actually include all of our xorg into the build context. I don't buy that explanation. Doesn't make sense. Like, why do we need all of xorg? We could just like pass in libx11. Then if what they're saying is true, then it means I should be able to do this. And then it shouldn't be a syntax error, right? I mean, like, what are they talking about? Yeah, I can't even reference it now. Yeah, there's just no way for this to work. I can't reference it. So at least this way I can reference Xorg. Anyway, build failure. No way to make install, so no install phase. So there's something called, there's an install phase. Standard environment is automatically working with the makefile that comes with the icat. With icat. The console output shows that configure and make are executed without issue, so icat binary is compiling successfully. It's just when it's trying to... So does that mean we actually have an icat? Where is it putting it? Maybe it's all in this, no. Bash? No, that's not it. Yeah, I don't actually, next door. Oh, maybe it's in here. What is this? Next door minus L, this thing? Oh. It unpacks it into here. Well, it doesn't matter, right? It's not a big deal. It's just curiosity. So then it's going to try to run make install, and it doesn't have a install target in the make file. If you don't know make files, don't worry about it too much. The README in the icat only mentions how to do make. Add this step to your derivation using the install phase attribute. So we're going to have an install phase, and it's just like what to run, I guess. All right, so let's do that. It's called install phase, and this is a multi-line string, and we're going to, I guess out is a special special thing we can put that always is basically where the results are, and we're going to copy icat to out bin. Yay, so now we should be able to run result bin, which is the directory we created here, and then there should be an icat. Oh, I guess we have to give it like some value, right? I don't really know what to give it. But anyway, it doesn't matter. We have a function, we have a build that works. So there's several phases it looks like. There's install phase. Build phase. I see. It's good practice when packaging software with Nix to include calls to these hooks and derivations you define, even when you don't make direct use of them. I see. Because like other people may override us and they want to like say, hey, here's a pre-install, but if we made a new install phase that doesn't call this, then it won't be able to use it. So let's put this into our build cheat sheet. Missing install phase. Oops. Oops. And this we want to say is basically you can define install phase in your derivation if the package you're building doesn't have a make install target. Do add the other hooks in case someone else wants to override their values. There we go. That looks okay to me. All right. Yay. All right, so we've done this, and now we're basically up to, I think, dependencies in the development environment. Well, that's kind of weird, right? Why did it skip? What just happened? Next steps. I see. Their next steps don't. Dependencies in the development environment, automatic environment activation with dir env. But here, we don't see that. We're almost up to NixOS. I just installed NixOS on an older machine I have because on here I'm running it in under Windows subsystem for Linux. I think that's what it's called, right? I always forget. But yeah, it was pretty easy to install, so I'm pretty excited to like. I've been using Nix so much in terms of advent of code and everything, but I actually had no idea how to like do anything with my Nix OS system because I don't really know it. But looking forward to getting there. Let's see. We've been at it for about an hour. I said that I would make progress on these things, but I don't think I'm gonna like do the next one just yet. Maybe I just have to go to the bathroom. Yeah, let me go to the bathroom and then I'll decide. I'll be right back. It's so cold. Maybe I should put on a sweater. How's everyone doing? We just did some Nix reviewing. I think I will do a little bit more next, just to like make progress. It's a shame, like, because what if I don't do it? I'm gonna like not do anything. I'm gonna like forget again and then want to review again. So now that we've reviewed, why don't we make a little bit of progress? All right, so that means we're gonna do it in order of this thing here, which means we're finished with this, right? We finished this. Yeah. And now we're going to do working with local files. Learn to package your own projects with Nix. That sounds fun. Yeah. Let me just put this on. Are you guys living somewhere cold also? Is it nice? Working with local files and Nix. To build a local project in a Nix derivation, source files must be accessible to its builder executable. Since by default the builder runs in an isolated environment that only allows reading from the Nix store, the Nix language has built-in features to copy local files to the store and expose the resulting store paths. Oh, interesting. So this is basically like when we're not using fetch. Like before we were like fetching stuff. So here we have local files that we want to build. So we'll have to somehow move them into the store. All right. Using these features directly can be tricky, however. Coercion of paths to strings, such as widespread patterns of source equals dot slash dot, makes the derivation dependent on the name of the current directory. Furthermore, it always adds the entire directory to the store, including unneeded files, which causes unnecessary new builds when they change. Huh. I see. The source they're talking about here is this source over here. So make derivation takes in a source parameter. So if you said source is just basically the local directory, your current local directory, then your derivation on the name of the current directory, and also it adds the entire directory to the store, right? So maybe you'll have like extra stuff in your current directory you don't need um, for building purposes. So I guess that's their point. Um, the built-ins path function and equivalently libsource's clean source with can address these problems. However, it's often hard to express the desired path selection using the filter function interface. Alright, we'll see more of what that means. In this tutorial, you'll learn how to use Nix packages libfileset library to work with local files in derivations. It abstracts over built-in functionality and offers a safer and more convenient interface. I think this is just like, I kind of bitch about this with Nick sometimes, but like the documentation sort of like, it makes sense, but it's a little hard to read. Like this is a little hard to read, like what they're talking about here. And they make lots of references to stuff like the built-in path function can address these problems. Like, all right, how? Like, how does it make this better? Like, I don't know. I don't know how that really helps. And equivalently clean source with. Allowing you to chain multiple calls together. Calls. Um, I don't really know. Anyway, I think it'll become clear. I find with Nick's documentation, it makes sense after you finish the documentation, which isn't really the way you want it to be, but that's how it seems to be a lot. So let's go on. File sets. A file set is a data type representing a collection of local files. File sets can be created, composed, and manipulated with various functions of the library. You can explore and learn about the library with Nick's REPL. So I did not know about this. -F. Nick's REPL. What does the F do? There are a lot of options. Oh my god. Holy cow. -file. That's not it, right? Log format. -F. Oh, I see. It's just going to basically pull this file. Interpret installables as an attribute path relative to the next expression stored in file. What does this mean? Installables as attribute paths relative to the next expression. God damn it. Anyway, this looks really nice. I think what this means is now it's going to download Nick's packages, this version, and inside of it has a lib. So now I can access lib. Because normally inside Nick's REPL, I can't do something like lib.fileset. It says like I don't know it, right? But I guess if I pass in I shouldn't probably type this because it has to download it. Does it mean it's ready? I guess so. And now I can do, oh, no I can't. It's still like busy. I know I've been using oh, what just happened? Holy cow. Here, let's just start over. Because this time it has it downloaded now. Okay, so it's fine now, it's happy. Now I have lib.fileset. It should be a function. Well, it's something. Alright, so fileset is equal to lib.fileset. Just makes it easier for us to type. The trace function pretty prints the files included in a given file set. So that means file system dot file set dot trace, and we give it a path. I'm not sure what null is. Project Nix null. All right. Home user. So it just prints my current directory. Yeah, that's what it does. All right, that doesn't do too much, right? I see. It's a file set, so when I do /dot, it includes, it's basically saying all files in this directory. Got it, got it. So it's going to include all the files that I have. All functions that expect a file set for an argument can also accept a path. Such path arguments are then implicitly turned into sets that contain all files under the given path. Right, so when you do dot slash dot, it's going to turn that file set into all files in that directory. The trace function pretty prints its first argument and returns its second argument, but since you often just need the pretty printing in Nix REPL, you can omit the second argument. I see, just like the Nix trace in packages or where built-ins, it's going to return the second argument. All right. That means I have to get ready soon. And look, this is kind of a long thing. I might not be able to finish. All right, let's keep going then. Let's do this fast. How fast can we do this, guys? Let's see here. Even though file sets conceptually contain local files, the files are never added to the Nix store unless explicitly requested. Therefore, you don't have to worry as much about accidentally copying secrets into the world readable store. Oh, I see, the Nix store is world readable. Okay. In this example, although we pretty printed the home directory, no files were copied. This is in contrast to coercion of paths to a string such as $dot/dot, which copies the whole directory to the Nix store on evaluation. Yeah, we learned that when we use pads in string interpolation, it copies it into the Nix store. So that's something to be careful about. When using flakes and Nix command experimental features, the local directory within a flake is always copied into the Nix store completely unless it is a Git repository. I don't know what flakes are, so I can pretty much ignore that. This implicit coercion also works for files. Touch some file. All right, so let's do that. My file. Then we do Nix REPL again. Uh-oh, I've lost my Nix REPL. Ay. Nix REPL. And then it was like channel. Don't I have channel in here? Ay. 2311. There we go. This is so helpful that I should add this to my cheat sheet. I don't think I have Nix REPL. I'll make one for Nix REPL. Oh, tips. Run Nix REPL with -f to make lib available. That's super useful. All right, what we're doing now, we're touching some file, and then we do files fs dot trace, but I don't think we have fs, right? What did we do here? Fs is equal to lib file set. Let's just remember that instead. lib.fileset.trace some file, my file. So it says my file regular. It also prints the file type. Where did it take me? I swear to God. Okay. Example project. To further experiment with the library, make a sample project. Create a new directory, enter it, and set up endpins to pin the Nix packages dependency. What are we doing here? What is going on? So we make file set. We go into file set. Nix shell minus p endpins. I never learned what set up endpins to pin the Nix packages dependency. Did we learn what endpins were somewhere? Because I certainly don't know what it is. Endpins is a simple tool for handling different types of dependencies in Nix project. Track Git branches, releases, channels. Alright. Endpins in it. Tree, endpins default Nix sources.json. Oh. Huh. I don't really know exactly, but it sounds like it's able to kind of figure out what you're using right now and then just like set the version numbers. So let's just follow what it says here. I hate kind of blindly following stuff, you know? Here, we'll just copy this. What is it saying? It is creating endpins directory, adding Nix packages. Endpins run endpin init. Endpins add GitHub, NixOS, Nix packages, branch, NixOS 2311. I see. So we're telling it what channel we're using here and which things we sort of want to pin down, I guess. All right, we'll see what this actually ends up doing, but that's good to know. Then create a default.nix file with the following content. So let's get out of here and let's go into file set and we'll make something called default.nix. Oh, that was really slow. We have a function. It takes in something called system, which is by default current system. And it takes in sources, which is going to import endpins. All right, I have no idea what that is. And then we do let packages equals import sources dot Nix packages. I wonder, so it made an endpins directory. And it has Nix packages pinned here, version branch, version 3. Okay. And it has something in here generated by endpins. One day we'll learn about this. Kind of weird. Whoops. All right, we're back in file set. Sources Nix packages. Config is equal to, this is stuff we've seen before. Overlays is equal to empty list. But it is also bringing system down. Oops. we're bringing system into sources nix packages. And now we do in packages.call package build nix. Alright, we've seen this also. So basically build nix is going to take in parameters and call package is going to know how to supply them automatically. And inside of packages, we're going to have nix packages, sources, import endpins. Interesting. That's the endpins directory that we just set up, which I guess has nix packages in it. Okay. Add 2 source files to work with. Okay, let's do that. Echo hello to hello.txt. Echo world to world.txt. Cat hello.txt. Cat world.txt. There we go. Let's save this default.nix. Files in a given file set can be added to the nix store with toSource. The argument to this function requires a root attribute to determine which source directory to copy the source to the store. Only the files in the file set attribute are included in the result. So we're going to make build.nix. So here's build.nix. Build.nix. And it needs standard environment, which isn't surprising. It also needs lib. That's all the library functions in nix packages. And now we're going to say we can access lib file set. That's great. Source files is equal to hello.txt. That was the file we just created. In fs.trace source files. So it's going to print out source files, which is hello text. Why does it say files when it's just one file, right? And then it's going to evaluate its next parameter, which is actually standard environment.make derivation. This is actually more like this, right? This is the third argument. Second argument to trace. Name is equal to file set. I thought we always needed a p name. Source is equal to fs.toSource. Root is equal to our current directory. File set is equal to source files. And post install is make directory out. Copy -v hello.txt to the out directory. All right. I can't say that I understand the make derivation that well. Why does it take name instead of p name? Where's the version? And I still don't quite understand toSource, but we'll get there maybe. Try building it. Nix build. We don't need to pass a -a for nix build because in our default there's no options. There's just nix. There's only one. So we do nix build. It's going to fetch nix packages. Import endpins. I see. So endpins, it's going to import this. And here we read from sources.json. And basically it knows how to pull all this out. All right, so it's some kind of magic where endpins is going to contain Nix packages. That's kind of neat. I don't think we needed to do this, right? Um, yeah. Anyway, so it's just getting us source. It's just getting us the sources that we described for endpins early on, which was like, where was it? Here. Endpins add GitHub, NixOS, Nix packages. So maybe it's pinning those things. Anyway, let's I don't understand. I really don't understand. So here we've called Nix build. What has it said? It's doing a lot of stuff. And then running patch phase update. There's a whole bunch of phases. Hello text ends up going here into the Nix store. Checking for references, patching. Yeah, we saw this. And then we have a file set. So do we have a result now? Oh, we do. All right, so it's actually, it actually ran this post install, made the out directory, and moved hello text over to it. Source files equal trace source files. I see. File set is equal to source files, which just is right now is just a single file hello text. That's how we've constructed our file set. And I guess to source makes it treated as source code. All right, to be able to copy both hello and world.txt to output, add the whole project directory as source again. Okay, so here we're adding the whole project directory. And then we are only copying these two files. This will work as expected. All right, so now in result, we have hello and world, and if I cat world, it says world, okay. However, if you run Nix build again, the output path will be different. The problem here is that Nix build by default creates a result symlink in the working directory, which points to the store path just produced. Okay. I see. Because we made it our local directory, every time we run a build or anything, the local directory is changing. So it treats the local directory as something different and puts us in a different store. Since source refers to the whole directory, yeah, Nix will have to start over. Okay, difference. function subtracts one file set from another. The result is a new file set that contains all the files from the first argument that aren't in the second argument. Use it to filter out result by changing the source file's definition. I see. Okay, so here we go. Source files equals, and we're going to do fs.difference. We pass in our local directory, but now we're saying ignore result. And now it shouldn't put it into a new directory. Should always put it in the same one. Yeah, it's always this 25J file set. And before this, I guess, it would always put in a different directory. Let's just make sure that's true. Yeah, you see these are always changing. So just making a whole bunch of garbage. I like typing again, it's called fileset.difference. We pass in this and we tell it the thing we want to forget, right? Perfect. All right, missing files. Remove the result symlink creates a new problem though. Right, because there is no result anymore, so it can't do it. Different second argument result is a path that does not exist. Okay, looks like the answer is following the instruction and use may be missing. It said it right here, right? To create a file set from a path that may not exist. So here, oops. File set dot may be missing. Like this, right? Yay, that worked. So if it's missing, it'll probably just not put anything in there. It doesn't need to remove it if it's missing, right? Alright, so union, explicitly exclude files. When is my meeting? I have ADHD. I live in constant fear of forgetting everything. Alright, I should leave soonish, but we can go a little longer. Test passed. Thank you. From YouTube. How are you doing? How are you doing, YouTube? How are you doing, Twitch? You guys can hear me, right? Once I did a stream and I found out I was not talking the whole time. Someone's like, hey, I can't hear you. It's like, holy shit. New streamer problems. Now I have a checklist. It's just like Nix. It makes sure that nothing can go wrong. There is still a problem. Changing any of the included files causes the derivation to be built again, even though it doesn't depend on those. Append an empty line to build.nix. Look, here's our build.nix. I made a new line to it. And now when we build, it changed. It's in 5S instead of R3. It used to be R3s all the time. But now it'll always be the same 5S. It's saying it doesn't care about build.nix. What it cares about is hello and world, right? So why should changing build.nix change where it goes? Changes where it gets stored in the store. One way to fix this is to use unions. Create a file set containing a union of files to exclude. Subtract it and subtract it. Oh, we're doing kind of like surgery now. So here's our file difference. So we're going to remove a bunch of things. So instead of just this one function, let's try to make this clear. difference. Difference takes in parameters. And here's its second parameter. And the parameter is a union. We're going to add several things. And union takes in a list of stuff. And the first item is maybe missing. We need parentheses around it so it knows how to parse it. Otherwise, it's going to be a list of a function. And then we're going to get rid of default.nix, build.nix, and endpins. And that is the list. And this is the union. And that is the end of this. Oh, why is default.nix not in here? Oh, we don't need a... Nix doesn't use commas in its lists. Alright, I think that's right now. So now, uh-oh. File set differences, dot dot. Now we do the union. Union takes in a list of things. This is the end of the list. This is the end of FS unions. And then we have a semicolon. Why is it not happy? Second argument is type lambda. Oh, because I typed unions wrong. Okay, so now we're in, you can see here, 3HZ. And now if I change build.nix to have even more new lines, oops, more new lines, it's still 3HZ, perfect. Right. File filter function allows filtering file sets such that each included file satisfies the given criteria. Use it to select all files with a name ending in .nix. Okay, so we get rid of these nix files here, and we're going to add something called file filter, which is a function that takes in a function, that's the predicate, and the directory that it's going to look in for each file. The predicate takes in a file, and I guess we are going to check file.hasExtension. I didn't know there was such a thing. So that means paths have reference manual path. Let's look up path. Wonder where path is in here. Oops. What happened? Path. This is not going to be helpful this way. Just kind of wanted to know, like, what are paths in Nix? Ah, well, maybe we'll have to look at it some other time. But apparently paths have this has extension. So let's just test that out. So if I do like hello.text, you see it returns me this path. So does that mean a path has, that doesn't make sense, right? I can't do dot has extension. f equals hello dot text. All right, f dot has extension text. So I wonder how this worked, because this is a path. Oh, yeah, this is a set of, these are a set of files. It's a directory. Oh, maybe. File set. Yeah, I don't really understand how that works. File filter. Oh my god. File filter will take in the current directory, and then maybe it will like basically look for the files and pass it into this function. I'm guessing that's how it works. So there's paths on their own don't have a has extension. So where was I? Build.nix has extension nix. So here we have, we can see that even if I change this file, we end up in the same directory. But if I mistype nix to that, and I've changed the file, now we're in a new one, sk0, and I change it again, it'll change again. Yeah. So this is actually working. All right, so that's pretty cool. Notably, the approach of using difference explicitly selects the file to exclude, which means that new files added to the source directory are included by default. Depending on your project, this might be a better fit than the alternative in the next section. Okay, union, explicitly include files. To contrast the previous approach, unions can be used to select only files to include. So this is useful if you know all your files you're including, but every time you add a new file, then like you might forget to add it to your union, right? So so we're gonna make a build.sh and a select.c and an h. So you see we have extra files now. Oh, I typed it wrong. Because I didn't make directory source. Let's remove source.select.c and source.select.h. All right, so under source now, we have select.c, select.h, and we also have a build.sh. Then create a file set from only the files to be included specifically. All right, so here we just have a union. We get rid of our difference. We just make a union. And the union is a list. We'll do it their way. Where I'll just get rid of all this. Actually, it's easier to just. All right, what's in the union? We have our hello.txt, we have our world.txt, we have our build.sh, and we have, now we're trying to get fancy and add all c and .h files under source. So let's try to remember how to do this. That is like fs.file filter. I can't remember what it's called. Filter file maybe. And it takes in a function, and it also takes in a directory, which probably is our source directory, right? and it needs to start with a dot. And now we call file.hasExtension, and it can either be a .c or file.hasExtension .h, right? So we need to put these in parentheses, otherwise it can't parse these. So let's see, this ends the function, this is the source. That seems right to me. I'm guessing I typed it wrong though. Attribute filter file, not function. Okay, so it wasn't filter file, it was called file filter. I think I had that that last time, didn't I? Hey, did I do it right then? Let's see. I'm just gonna glance at the code. Yeah, that looks right. So now in result, we have hello world, hello text and world.txt. And now if I change like select.c in here to have something, it should not change the directory. Wait, was that right? Oh, it should, because that was, I'm including this. But if I change my default.nix, it shouldn't change where it's building this. We're in 1rm, 1rm. Great. So that makes sense. The post install script is simplified to rely on the sources to be pre-filtered appropriately. Oh, they changed post, they added, what did they do? Source files, make derivation, file set, this is all the same. And then post install, copy minus vr dot out. So this is saying that because we included our files in our build directory, it will only have the source, it will only have the source files to copy. Let's see what's in there. Yeah, so it basically has the stuff that we added in here only that was copied over, because I guess that's how we defined its source. That's how we defined our source. Recursively, I guess that creates the out file. Recursively, yeah. All right. Am I late yet? Not late yet. Getting close. The post install script simplified it. Only specified files are used even when a new one is added. So if I add a new file in here and I run nix build, it won't do anything. You can see the files that it actually copied. It wasn't in there, and there was no select.o. Matching files tracked by Git. If a directory is part of a Git repository, passing it to Git tracked gives you a file set that only includes files tracked by Git. Oh, interesting. Create a local Git repository and add all files except select O and result.o to it. Okay. So we're adding everything, and then we remove select.o and result. Okay. Now reuse this selection of files with git tracked. So source files is equal to git tracked. Let's see what ends up being copied over. All right, so we got rid of select dot, what did we get rid of? Select result and select dot o. So we don't have, if we go into source, we don't have select, wait, we do have select o. No, in result though. Yeah, we don't have result.o in our result. So that makes sense. Not all of these files are needed to build a derivation. Intersection is where intersection comes in handy, that are in both of the two file sets. So we say it's in git tracked and these files. I don't know, it seems a little bit like, now it seems like we're like picking at straws here, because you kind of have to know everything no matter what here, right? So we have our git tracked stuff, and we're saying it also needs to be in the union of these other files, which is hello.txt, world.txt, and build.sh, and source. So it's the intersection of these things. All right, so this means pretty much everything that's git tracked and source, and then these files also. But here, our build.nix files and all that aren't included because they're not, they may be git tracked, but they're not in this list. Intersection. What am I doing wrong? Git tracked. FS union. I did the same exact mistake as last time. It's unions. And now we have this. All right, just in time. What did we really learn? The whole endpins thing were confusing because we didn't learn it, right? But I don't think that really matters too much. It just matters that you have some source files. So let's look at default again. You have some source files. That's what's really important, right? What else? So we're going to be calling, we have system, inherit system, built-in current system. I don't think we ever use system in here, right? No, we don't use system though. So I wonder why system is being passed in here. I guess, oh, yeah, I don't know why. Packages, maybe we need to know, maybe it needs to have system inside of packages later. But it doesn't matter. So we have source files, and then we can kind of define what our source files are using this file set functions, right? We have intersection, we have git tracked, we have unions, we have difference. And that way, when we actually do a build of our local files, we're not rebuilding every time like something that doesn't matter changes, right? It's really only when our source code changes and stuff like that that we need to rebuild. And then we have our normal make derivation. Trace here is just over here, it's just printing out the source. We can remove that and it'll still do the work. This is sort of not really important. You see it does it, but it doesn't change. It says it's dirty because I haven't committed my changes in Git. That's a good warning. I think this was good. I think most of the time you wouldn't be doing Nix builds with local files. My guess is that you'd pull it from a repository, but you know, we'll see. Maybe sometimes it's useful. Oh, thanks, PF Morph, for letting me know my audio's good. I don't look at chat enough, right? So I think we are all done for today. I'm going to go to my meeting, maybe get myself a job. We'll see how that goes. Thanks so much for hanging out with me. I think we'll put this video up as a video clip later, you know, just a section here where we're doing something new. Maybe the review is nice also. You can catch that again later. So yeah, do like, subscribe, follow, whatever it is on your platform. And if you enjoyed this, I also have a Discord server that's in the description. So yeah, thanks for hanging out with me. We'll learn something more. We'll go back to, we got COBOL, we got Atari assembly for the 8-bit. We have Rust that I still want to do. And we have some Haskell. So those are things that we're going to get back to doing. All right. Thanks, everyone. Talk to you later. Bye.